Today, you're going to learn how to do every single sample question that Accuplacer provides for the arithmetic test. I'm Jonathan, former high school math teacher, and if you want to make sure you can crush the arithmetic test and have a shot at taking the QAS test and placing into a college-level math course, thus saving you time and money, then make sure you study the rest of this video. Let's do the work. This question is assessing your ability to convert a number in decimal form to fraction form. And so one thing that's very important here is to understand that this 0 here is in the tenths place, and this 6 here is in the hundredths place. And if we were to write another 0 here, this would be in the thousandths place. And because the 6 is in the hundredths place, when we go to write this number in fraction form, that means 100 is going to be in the denominator, or the bottom of the fraction, and 6 is going to be in the numerator, or the top of the fraction. And so the answer is 6 over 100. To check your work, 6/100ths is the same as 6 divided by 100. So you can go onto your calculator and put in 6 divided by 100, and the calculator will spit out 0.06. And so you'll see that 6/100ths is the same as 0.06. Now in this problem on Accuplacer, you will not be able to use your calculator, but to check your work in this moment, to check your understanding, it's helpful to see that yes, indeed, 0.06 is the same as 6 over 100. That is the correct answer. Now let's try some different problems to make sure you really understand how to convert a decimal into a fraction. Go ahead and pause this video, try these problems, and then we'll do these together. Okay, now that you're back and you've tried these problems, let's do these one by one. So how do you convert 0.4 into a fraction? Well, 4 is in the tenths place. That means that 10 is going to be in the denominator of our fraction, and 4 here will be in the top. So the fraction would be 4/10. How about number 2? Well, we have 0.82. The farthest this goes is to the hundredths place. And so that means that 100 is going to be in our denominator, and the numerator is going to be 82. The answer for this one is 82/100ths. And for number 3, we have 0.903. So the furthest this goes is to the thousandths place. So that means 1,000 is going to be in our denominator for this one. And in the numerator, it will be 903. So the fraction would be 903 over 1,000. So in this problem, you're trying to figure out how many total items are going to be at the auction. 36 people each bring 12 items to this auction. How many total items will there be? I'm just going to give you the answer here, and then I'll explain why this works. So the answer is going to be 12 times 36, which is going to equal 432. So the first thing we need to figure out is, why do we multiply 12 times 36 instead of adding or subtracting or dividing or whatever? Why does 12 times 36 make sense? And then the second thing we need to do is figure out how to multiply 12 times 36 without a calculator. So let's do the first step. Why does it make sense to calculate 12 times 36? So let's say, for pretendsy's sake, that only one member brings 12 items to this auction. Well, how many total items would there be then? Well, one member brings 12 items. That's all there is, just 12 total items. So let's say, for pretend sake, that two members bring 12 items to this auction. So that would be a second member bringing 12 items. How many total items would there be? Well, there'd be 12 plus 12 items, or 12 adding to itself 2 times, or in other words, 12 times 2, which is 24 items. All right, so 24 total items. How about if 3 members bring 12 items to this auction? Well, there'd be a third member bringing 12 items. That would be 12 plus 12 plus 12. Or in other words, 12 adding to itself 3 times, or 12 times 3, which is 36. Or let's just keep going here one more time. If 4 members, let's say this is 4 members bringing 12 items, then that would be 12 plus 12 plus 12 plus 12. Or in other words, 12 adding to itself 4 times. Or in other words, 12 times 4, which is 48. And so we see a pattern. If 5 members bring 12 items, then this would be 12 times 5. If 10 members bring 12 items, then this would be 12 times 10. Or if 36 members bring 12 items, well, then the calculation is 12 times 36. 12 times 36 will give us the total number of items at this auction. So how do we multiply 12 times 36 without a calculator? The first step is to stack these two numbers one on top of the other like so. And you'll see I've done this in two different instances. That's because I'm going to show you how to do this in two different ways. The first way is the way that they all taught us in elementary school. It's a very shortcutty way of doing things, which is great if you're trying to multiply it quickly. It's also kind of confusing if you're just learning this for the first time, or if it's been years and years and years and years since you've learned this. It can be a little confusing this way, which is why I'm going to do it a second way to really draw out and make it really clear what's going on here, and you'll see step by step by step what is actually happening. And then in the end, you'll be able to pick which way you like better and just stick with doing it that way. Let's do it the way that they teach us in elementary school first. So we're going to start by multiplying 12 times 6. So let's do that. We first multiply 2 times 6, which is 12. So we write down the 2 and we carry over the 1. And then we're also going to multiply 1 times 6. So let's do that. 1 times 6 is 6, plus 1 is 7. And so we're going to write down 7 here. So 12 times 6 is 72. And then we're going to need to multiply 12 times 3, or really this 3 is in the tens place. So we're really multiplying 12 times 30. But first, we're doing this on a second line, and we're going to need to buffer this with a 0, because again, we're not multiplying by just 3, we're multiplying in the tens place by 30. So we need an extra 0 here. This is where things get a little shortcutty. This is where things get confusing. So if this is confusing to you, just wait for the second time that we do this around. We won't have to mess with adding this buffer of a 0 here. But let's move forward. So 3 times 2 is 6. And then 1 times 3 is 3. And so we get that 12 times 30 is 360. And so now we just have to add these two pieces together, 72 plus 360. So let's do that. 2 plus 0 is 2. And 7 plus 6 is 13. So we write down the 3 and carry over the 1. And then 1 plus 3 is 4. And so the answer is 432. So let's do it a different way. Let's go over here and do this once again, but with less shortcuts. Let's do, once again, 12 times 6 is going to be the first thing that we do. And so we're going to go ahead and do 2 times 6. But this time we're just going to write out what that is. So 2 times 6 is 12. So let's write that down. And then next, we're multiplying 1 times 6. But really, this isn't just 1 times 6. This is 10 times 6. This 1 is in the tens place. This is really 10. So we're really multiplying 10 times 6, which is 60. So we'll write that down. So we're going to need to add 60 to it. And then we're going to multiply 12 times 3. But once again, this isn't just 3. This 3 is in the tens place. So we're really multiplying 12 times 30. So let's do that. 2 times 30 is 60. So let's add another 60. And then finally, we have 1 times 3. But again, this isn't really 1 times 3. This is 10 times 30. And 10 times 30 is 300. So let's add 300. And now we've multiplied everything together. We can just add everything. 2 plus 0 is 2. And 1 plus 6 is 7, plus 6 is 13. So we'll write down the 3 and carry over the 1. And then 1 plus 3 is 4, and we once again get 432. And so you see that there's two different ways of doing it. You can pick your favorite, whichever way you like, but ultimately pick one, stick with it. This is how we multiply two-digit numbers together. So in the end, when you have 36 members in a club, each giving 12 items to an auction, in the end, that would be a total of 432 items in the auction. This problem is assessing your ability to combine fractions, in this case add fractions. We're going to run through this problem, and then I'm going to explain why we're doing some of the things that we're doing when solving this problem, so you really understand how to do it and also why things work. And then after that, we're going to go through a bunch of different problems. We're going to cover addition, we're going to cover subtraction, multiplication, all of it. We're going to do all the different types of problems so that you can really field any kind of problem that they give you on the test. So we're going to cover all of it. But let's start with some fraction terminology. So when we say this expression, we can say this in one of two ways. We can say this as 4/10 plus 3/100ths, or we could say this as 4/10 plus 3/100. It doesn't really matter. But what does matter is that there is some terminology that you'll hear a lot, and the top number of the fraction is called the numerator. It's very important to remember this because you'll hear it all the time. And the bottom number of the fraction is called the denominator. So numerator and denominator. You want to write that down or have some way of remembering that. You'll be hearing that a lot from me and from everyone else. Okay, so that's it for terminology. Let's solve this problem. So 4/10 plus 3/100. How do we do this? Well, when we're adding or subtracting fractions, in this case, adding, we must have the denominators, right? The bottom number of the fraction be the same, and we do not have that. So we have 10 in this denominator and 100 in this denominator. We must have these be the same before we do anything else. So how do we do that? Well, we take the smaller number, in this case 10, and we ask ourselves, does 10 multiply into the bigger number 100? And in this case, the answer is yes. 10 does multiply into 100. Well, how many times? Or in other words, 10 times what number equals 100? Well, 10 times 10 equals 100. And so what we have to do next is multiply 4/10 by 10/10. And I'll explain why this works, but for now, let's just roll with it. So the next step is to multiply these two fractions together, and then we'll be able to add. So let's go ahead and multiply 10/10 times 4/10. How do we do this? Well, when we multiply fractions, we just multiply across. So 10 times 4 is 40. And in the bottom, 10 times 10 is 100. And then we have just 3/100 over here. We're still adding that. So now we have 40/100ths plus 3/100ths. Now the denominators are the same. So now we can add these two fractions. So how do we do that? Well, we keep the denominator the same. So we're still going to have 100 on the bottom, but we add the numerators. So 40 plus 3 is 43. And so therefore the answer is 43/100. So to really illustrate this, so you can understand why we must have the denominators be the same when adding or subtracting fractions, think about lemon meringue pie and strawberry rhubarb pie. So let's say that you eat 1/2 of a lemon meringue pie. Well, you'd cut the pie in 2 slices in half, and you would eat one of those slices. And as a fraction, that's represented as 1/2. You cut the pie into 2 slices, and you ate 1 slice. And let's say that you ate 2/4 of a strawberry rhubarb pie. Well, that would mean you cut the pie into 4 pieces, and you ate 2 of them. And as a fraction, that's represented as 2/4. You cut the pie into 4 pieces, and you ate 2 of them. So if you ate 1/2 of a lemon meringue pie and 2/4 of a strawberry rhubarb pie, how much pie would you have eaten in total? Well, in total, that would be 1 whole pie. And so when we add these fractions, 1/2 plus 2/4, we would expect the answer to be 1. To illustrate why these fractions must have the same denominators when we add them, to illustrate this, let's just do it the wrong way. Let's do it the totally incorrect way and just add these fractions without the denominators being the same and see what happens. We're going to run into some troubles here. So let's do this the incorrect way just for funsies. So 1 plus 2 is 3. And 2 plus 4 is 6, and so we would get that the answer is 3/6, which simplifies to 1/2. But that doesn't make any darn sense, does it? If you eat 1/2 of a lemon meringue pie and 2/4 of a strawberry rhubarb pie, again, you expect the total amount of pie that you ate to be 1. But this is saying that the total pie you ate is 1/2. That's garbage. That doesn't make any sense. That's totally incorrect. And so what we have to do in our diagram over here is restate this 1/2 in terms of fourths. Because if both of these pies are cut into fourths, well, it's easy to tell how much pie you ate. You just say it in terms of fourths. How many 1/4 slices did you eat? Well, we ate 1, 2, 3, 4 slices. And so that would be 4/4, or just 1 whole pie. And so that's what we need to do, but in fraction form over here. So how do we turn this 1/2 into 2/4 like we did in this picture? Well, we ask ourselves the question, 2 times what number equals 4? Well, 2 times 2 equals 4. So we take this number and we multiply 1/2 by 2/2. This same number here, we put this number here and here. And so now we just multiply. And when we multiply fractions, we multiply across. So let's do that. Let's multiply these. 2 times 1 is 2. And 2 times 2 is 4. And then we can just bring the rest of this expression down. We have plus 2/4. And so now we've rewritten 1/2 as 2/4, just like we did with this pie over here. We had it stated as 2 slices and we ate one of them, or 1/2. Now we have it written as 4 slices and we ate 2 of them, which is exactly what we did here. And also note that when we multiply 1/2 by 2/2, 2/2 is just 1. 2 divided by 2 is just 1. And so we're multiplying 1/2 by 1, which is just 1/2. We're not changing the value of 1/2. 2/4 is the same as 1/2. We're not changing the value. We're just restating 1/2 in terms of fourths. And now we have the denominators the same. We have fourths, just like we have in this picture. And so when we go to add these two fractions, we keep the fourths in the denominator because that doesn't change. We do not add 4 plus 4 in the denominator because we're just having these pies stated in fourths. So we're stating the pie in fourths. That doesn't change. The 4 stays in the denominator, but we add the numerators because we're asking how many fourths did you eat? How many slices did you eat? Well, you ate 2 slices and another 2 slices, which is 4 slices. And so now we have 4/4, which is equal to 1. 4 divided by 4 is 1. And 1 was the expected answer. When we ate 1/2 of a lemon meringue pie and 2/4 of a strawberry rhubarb pie, we expected that we ate 1 whole pie, and that is the answer we got. So that hopefully illustrates to you why it's important to make sure that the denominators are the same in the fractions when you are adding or subtracting fractions. So now you've had a taste of what it's like to add two fractions together with unlike denominators. And there's all types of different things you can do with fractions. You can simplify, you can add, subtract, multiply, divide. There's improper fractions, there's mixed fractions, there's all kinds of things you can do with fractions. And so it's time to practice all of those. I've written out 10 problems for you to practice, each presenting their own unique challenge, each teaching something different. And so go ahead and try as many of these problems as you can and see which ones you can get, see which ones are stumbling blocks, and then we will come back and work on these together. So go ahead and pause this video now, try as many of these problems as you can, and then when you're ready, hit play on the video again, and then we will go through these together. So how do you simplify 50 over 100? First of all, what is simplifying and why do we do it? Well, in math, you want to present your answer in the simplest way possible, just like you do in life. Like for example, if you were to eat a strawberry rhubarb pie and you cut the pie into 100 pieces, and you ate 50 of those pieces, and you said to your mom, "Hey mom, I ate 50 100ths of a strawberry rhubarb pie." Your mom would think you're insane, right? Like that's a ridiculous thing to say, to cut a pie into 100 slices and eat 50 of them. Just cut the pie into 2 slices and eat 1 of them. Right? It's half the pie either way. 50 100ths is the same as 1/2. It's just that 1/2 is a lot simpler way of saying 50 100ths. And so that's what simplifying is. It's taking a complicated thing like 50 over 100 and stating it in the simple truth that, yeah, the value of 50 100 is just 1/2. I ate 1/2 of the pie, right? So how do you mathematically take 50 100ths and simplify it to 1/2 without drawing pictures of pies? Well, we ask the question, what is the biggest number that multiplies into both 50 and 100? And the answer is 50. 50 is the biggest number that multiplies into both 50 and 100. Second thing is, how many times does 50 multiply into 50? Well, 50 multiplies into 50 one time. All right. How many times does 50 multiply into 100? Well, 50 multiplies into 100 2 times. 50 times 2 equals 100. So that is how we simplify 50 100ths into 1/2. And 1/2 is as simplified as we can get, so the answer is 1/2. So how do you simplify 10 over 25? Well, it's the same process as number 1, but the result ends up being a little bit differently, so I wanted you to practice with this as well. So simplifying 10 over 25. The first question we ask is, what is the biggest number that multiplies into both 10 and 25? And the biggest number that multiplies into both 10 and 25 is 5. And then the next question we ask is, how many times does 5 multiply into 10? Well, 5 multiplies into 10 twice. 5 times 2 equals 10. So we can write a 2 in the numerator. And then how many times does 5 multiply into 25? Well, 5 times. 5 times 5 is 25. And so we can write a 5 in the denominator. And 2/5 is as simple as we can get. And so when we simplified 10 over 25, we got 2/5. So how do you add two fractions? How do you add 3/7 plus 2/7? Well, when we're adding fractions, it's very important that the denominators are the same. And in this case, are the denominators the same? Yes, the bottom number of the fraction is the denominator, and they are both 7. And so what we can do is when we're adding these fractions, we keep the denominator the same, and we add the two numerators. So we're going to add 3 plus 2, which is 5. And we ask ourselves, is 5/7 as simplified as we can get? Yes, it is. And so the answer is 5/7. So how do you subtract 1/6 from 5/6? Well, when we're subtracting fractions, once again, just like adding fractions, it's very important that the denominators are the same, that the numbers on the bottom of the fractions are the same. And in this case, are the denominators the same? Yes, they are. They are both 6. And so what we can do when we're subtracting these fractions is keep the denominator the same, which is going to be 6, and we subtract the numerator. So 5 minus 1 is 4. And is 4/6 as simplified as we can get? Actually, no. So we're not quite done yet. Whenever we have a result, we need it to be as simplified as possible. So 4/6 is technically correct, but we want to simplify it whenever possible. You know, if you're taking an exam and the exam gives you 5/6 minus 1/6, and 4/6 is not listed in as A, B, C, or D as the options, well, the simplified version might be listed. And so they might be testing you not only on subtracting fractions, but also on your ability to simplify the result. So how do you simplify 4/6? Well, you ask the question, what's the biggest number that multiplies into both 4 and 6? Well, 2 is the biggest number that multiplies into 4 and 6. And so how many times does 2 multiply into 4? Well, it multiplies 2 times. 2 times 2 is 4. All right, how many times does 2 multiply into 6? Well, 2 multiplies into 6 3 times, or 2 times 3 is 6. And so the answer is 2/3. So how do you add 1/3 and 6/12? Well, the first question we ask is, are the denominators the same? Because when we're adding or subtracting fractions, it's very important that the denominators are the same. So are the denominators the same? No, they're not. This denominator is 3 and this one is 12. And so to make these denominators the same, the first question we ask ourselves is, does this smaller denominator 3 multiply into 12? And the answer is yes, it does. Well, how many times? How many times does 3 multiply into 12? Or in other words, 3 times what number multiplies into 12? Well, 3 times 4 equals 12. And so what we do is multiply 1/3 by 4 over 4. And now we can multiply these two fractions. And when we multiply fractions, we just multiply across. So 4 times 1 is 4, and 4 times 3 is 12. And so we've restated 1/3 as 4/12. And then we still have this plus 6/12 over here. So we'll write that down. And now these two fractions are written with the same denominator, 12. Now we can combine these fractions. So let's do that. When we add these fractions, we keep the denominator the same, which is still going to be 12, and we just add the numerators together. 4 plus 6 is 10, and so we get 10/12. This is our result. Now, is our result in simplified form? No, it is not. We can actually simplify this further. So we ask ourselves, what is the biggest number that goes into both 10 and 12? Well, 2 is the biggest number that goes into both 10 and 12. So how many times does 2 multiply into 10? Well, 2 multiplies into 10 5 times, or 2 times 5 equals 10. How about 12s? How many times does 2 multiply into 12? Well, 6 times. 2 times 6 equals 12. And so the simplified version is 5/6. 1/3 plus 6/12 is 5/6. So how do you add 1/3 and 4/5? Well, this is actually a tough problem. This is, out of all 10 problems that I gave you, this is the toughest one. Just so you know, but we got this. We got this. We'll work through it together. It'll be grand. So 1/3 plus 4/5. First question we ask ourselves when we're adding fractions is, are the denominators the same? In this case, no, they're not. We have 3 and we have 5. They are not the same. And so to make them be the same, the first question we ask ourselves is, does this smaller denominator 3 multiply into this bigger denominator 5? And no, it does not. 3 does not multiply into 5. 3 goes into 3, 6, 9, but not 5. And so this is different than the problems that we've been doing. In the other problems we've been doing, this smaller denominator does multiply into this bigger denominator, and we know how to proceed from there. But this is different. This smaller one does not multiply into the bigger one. So we're kind of in a pickle. Where do we go from here? Well, we know that in the end, whatever the answer is, it's going to be a fraction. 1/3 plus 4/5 is going to be some kind of fraction with some kind of number up top and some kind of number on the bottom in the denominator. And we know that the denominator cannot be 3, it cannot be 5. So what can the denominator be? Well, whatever the denominator is going to be, we're going to need to be able to restate this 1/3 in terms of this number. And we're also going to need to be able to restate this 4/5 in terms of this number as well. Or in other words, we're going to need to be able to multiply 3 times something to get this denominator. And we're also going to need to be able to multiply 5 times something to get this number. And so in figuring out what this denominator should be, a shortcut is to just multiply 3 times 5. Multiply the denominators together. And so 3 times 5 is 15. And so we know that the denominator is going to be 15. And so now we need to restate 1/3 in terms of 15ths. And how do we do that? And so I say 3 times what number equals 15? Well, 3 times 5 equals 15. And so what we can do is multiply 1/3 by 5/5. And similarly for 4/5. So we're going to need to restate 4/5 in terms of 15ths. So how many times does 5 go into 15? Or in other words, 5 times what equals 15? Well, 5 times 3 equals 15. So we're going to need to multiply 4/5 by 3/3. And so now we can just multiply across. 5 times 1 and 5 times 3 is 15. And so now we've successfully restated 1/3 in terms of 15ths. 1/3 is 5/15. And then we'll do the same thing up here. So 4 times 3 is 12. And 5 times 3 is 15. And so now we've restated 4/5 in terms of 15ths. 4/5 is the same as 12/15. And now these fractions have the same denominator, 15. So now we can combine these fractions. So when we combine these fractions, we keep 15 in the denominator and we add the numbers in the numerator. 5 plus 12 is 17. And can we simplify 17 over 15? No, we cannot. And so the answer is 17/15. So how do you write 5/2 as a mixed fraction? Well, 5/2 is an improper fraction, meaning the numerator is greater than the denominator. And so to understand this with strawberry rhubarb pies, if you cut a whole bunch of pies into halves and you ate some slices, let's say you ate 1/2, 2/2, 3/2, 4/2, 5/2, that'd be the same thing as saying that you ate 2.5 pies. And so when we say 2.5, that is a mixed fraction. 5/2 is an improper fraction. 2.5 is a mixed fraction. They're both the same value. Both of them represent this amount of pie that you ate. They're just restated in different ways, improper and mixed. And so when we say write 5/2 as a mixed fraction, we say figure out how to write this in this form. So how do we do that without drawing pies? Well, whenever we have a fraction, we really have a division problem. This is really 5 divided by 2. Or, 1/2 is really 1 divided by 2. 4/5 is really 4 divided by 5. So 5/2 is 5 divided by 2. So we can write it as such. 5 divided by 2 looks like this. And now we have sort of a long division problem. Not really long division because we just have one digit here, but I want you to think about it in terms of division. This is 5 divided by 2. And so we solve it the same way as long division. How many times does 2 go into 5 without going over 5? So 2 goes into 4. That's the biggest it can go without going over 5. And 2 goes into 4 2 times. And so we just continue with our long division problem. 2 times 2 is 4. And so we can subtract 5 minus 4, which is 1. And how many times does 2 go into 1? Well, it doesn't. It doesn't. And so 1/2 becomes our, and so that is how we convert 5/2 into 2.5. 2.5 is our mixed fraction. So how do you write 2.5 as an improper fraction? So if we think about strawberry rhubarb pies, and if you ate 2.5 of these pies, well, another way of thinking about this is you cut these pies into halves, and you ate 1/2, 2/2, 3/2, 4/2, 5/2. So we can also say that you ate 5/2 of the strawberry rhubarb pies. And this fraction here, 5/2, is an improper fraction because the numerator is greater than the denominator. And so 2.5 and 5/2 are the same value. They're just restated in different ways. 2.5 as a mixed fraction and 5/2 as an improper fraction. So how do we turn 2.5 as a mixed fraction into an improper fraction without having to draw pies? So what you do is you draw 2.5. And we know that when we convert this into an improper fraction, it's going to have the same denominator as we have in our mixed fraction. So it's going to have the same denominator 2. And so how do we get the numerator? Well, all we have to do is multiply the denominator by the whole number and then add the numerator. So 2 times 2 is 4 plus 1 is 5. And so 2.5 written as an improper fraction is 5/2. So how do you multiply 2/3 times 8/11? Well, when you're multiplying fractions, you just multiply across. You do not need the denominators to be the same. When you're adding or subtracting fractions, you must have the denominators be the same. But when you're multiplying fractions, you do not need the denominators to be the same. You just multiply across. So let's do that. 2 times 8 is 16. And 3 times 11 is 33. And is 16 over 33 as simplified as we can get? Does 16 go into 33? No, it does not. Is there some other number that multiplies both into 16 and 33? No, there's not. So this is in simplest form. And so therefore 2/3 times 8/11 is 16 over 33. So how do you calculate 3/5 divided by 6/15? Well, it's almost the same as a multiplication problem. It's just going to be one more step here. So we're going to rewrite this line. It's going to be 3/5 times the reciprocal of 6 over 15, which is 15 over 6. So 3/5 divided by 6/15 is the same as 3/5 times 15 over 6, which is the reciprocal of 6/15. So what is the reciprocal? You just flip the fraction. So the numerator goes to the denominator goes to the numerator. It's just flipped. Instead of 6 over 15, it's 15 over 6. And so we changed this from a division problem to a multiplication problem. And now we know how to solve this. To multiply fractions, we just multiply across. And so 3 times 15 is 45. And 5 times 6 is 30. And that's our answer, but is it in simplified form? Well, does 30 go into 45? No, it does not. Is there another number that goes into both 30 and 45? Yes, there is. So what's the biggest number that goes into both 30 and 45? Well, 15 is the biggest number that goes into both 45 and 30. So how many times does 15 go into 45? Or in other words, 15 times what number equals 45? Well, 15 times 3 equals 45. And how many times does 15 go into 30? Well, 15 goes into 30 2 times. Or in other words, 15 times 2 equals 30. And so the simplified fraction is 3/2. Or in other words, 3/5 divided by 6/15 is 3/2. So if your eyes glazed over and you snored a little bit when you read that long word problem, you're not alone. I do the same thing for a word, like any word problem really. Word problems. Enough said. So anyway, when you're reading a long word problem or any word problem, what really helps is to break it down sentence by sentence, especially when they mention a number. You want to write down those numbers and what they mean. So what they mention is that there are 280 binders for attendees. So we have 280 binders for attendees, and the other number they mention is 31. There are 31 binders for presenters. And so the question asks, if there are 280 binders for attendees and 31 binders for presenters, how many total binders are there? So if you combine these binders, all of them together, how many binders are there total? And so the way you calculate that is 280 plus 31. And so how do you calculate a 3-digit number and a 2-digit number without a calculator? Well, the first step is to stack these two numbers one on top of the other. And the main insight here is to stack the digits in the ones place on top of each other, and then the digits in the tens place on top of each other, and then the digits in the hundreds place on top of each other. Because now all we have to do is add the digits in the ones place, and then add the digits in the tens place, and finally the digits in the hundreds place to get our answer. So let's do that. 0 plus 1 is 1, and 8 plus 3 is 11. And so we can write the 1 in the tens place and carry over the other 1 into the hundreds place. And then finally, 1 plus 2 is 3. And so the answer is 311. This problem is assessing your ability to evaluate percentages. How do you take two numbers, convert them into a fraction, and then into a decimal, and then into a percentage? So you sold 72 out of 150 cans of popcorn. And whenever you see this phrase out of, that's a big indicator that you're working with a percentage problem, and you can turn this into a fraction. So to turn this into a fraction, you put 150 in the denominator. You put the total amount, whatever it is, the total goes into the denominator, and 72 is going to go into the numerator. So you sold 72 out of 150, and so this is represented as a fraction, 72 over 150. And any fraction is actually a division problem. This is really 72 divided by 150, and so that's how we can convert this into a decimal. You just plug this into your calculator. You calculate 72 divided by 150 in your calculator, and it will spit out 0.48. And so we get 0.48, and to convert this into a percentage, you just move the decimal place 2 to the right. So you go 1, 2. And so we get that the percentage is 48%. And so out of 150 cans of popcorn, you sold 72, you sold 48% of your entire inventory of popcorn. 48% is the answer. So we need to determine which of these four numbers has the greatest value. And you are very likely to see something like this on your actual exam. Something with ordered numbers, you have to find the least or the greatest or something like that. And so there's two main insights I want you to take away from this. First of all is that it's hard to compare fractions to decimals. It's much easier to compare 2.28 to 0.199 and see which one is bigger. It's harder to do that with 8/3 and 2.28. So the first thing we'll need to do is convert these fractions into decimals. The second insight I want you to take away from this is that it's very important that you don't do any mental math on these problems. It's very tempting to do that, but when you do mental math, it's so easy to make mistakes. When you write everything down on paper, it's much harder to make mistakes because your brain lies, but your paper does not lie. So write everything down on paper. Even if it takes you an extra 30, 60 seconds, it's worth it to get the correct answer on these. So first thing we need to do is calculate 8/3 and figure out what decimal that is. So how do we do that? Well, any fraction is a division problem. This is really 8 divided by 3. So we can plug 8 divided by 3 into our calculator, and the calculator will say that that is 2.6 repeated. And then we still have 2.28, and then 10/12. This is really 10 divided by 12. So we can plug 10 divided by 12 into our calculator, and that will give us 0.83 repeated. And then we still have 0.199. So next step is to list these from least to greatest. It's very tempting to just pick which one we think is greatest at this point, but it really helps to just list these from least to greatest, so let's do that. These numbers both start with 2, and so those are going to be our bigger ones. These ones start with 0, these are our smaller ones. And then in the 10th place, this one has a 1, this one has an 8, and so 0.199 is the smallest, so we'll write that one down first. And then next smallest will be 0.83, so we'll write that one down. And then we go to these two numbers. So these both start with 2. In the 10th place, this one is 2 and this one is 6. And so 2.28 is the next biggest. And then finally 2.6 is the biggest. So now we've organized these from least to greatest. It's easy to see that 2.6 is the greatest value. And we said that 2.6 is the same as 8/3. And so 8/3 is the greatest number. So you have 130 straight up cold hard cash dollars, and you decide to deposit 25% of that. How much do you deposit into your savings account? That's what this question is asking. And I want you to first of all understand the differences between number 5 and this number 7. In problem number 5, it gave you two numbers and told you to find the percentage. In this problem, you're given one number and one percentage and told to find the number that you deposit into the savings account. And so between number 5 and number 7, it really covers the whole gamut of your skills using percentages. And so it's really important to be able to do both problems very well. And so in order to find the amount that you deposit, we need to take 25% of 130. And whenever you see this of, that's a big indicator that we're dealing with multiplication. But here's the thing, we can't directly operate with percentages. We can't directly add, subtract, multiply, divide using percentages. We first must convert this percentage into a decimal, and then we can multiply that decimal times 130, and that will give us our answer. So how do we convert a percentage into a decimal? Well, we have 25%, and to convert this into a decimal, we first recognize that 25 is really just 25.0, and so we just have to move this decimal 2 places to the left. And that would put us at 0.25. Remember when we were converting a decimal to a percentage, we just had to move the decimal to the right 2 times. But when we're converting from a percentage to a decimal, we go to the left 2 times. So 25% is 0.25. And so what we need to do is multiply 0.25 times 130 to get our answer. And when we do that, we get 32.5. And so in other words, when we deposit 25% of our straight up cold hard cash $130, then we will have deposited $32.50 or $32.50. So how do you add 1,582 plus 761? Well, the main insight here is to stack on top of each other the digits in the ones place, and the digits in the tens place, and the digits in the hundreds place, and finally the digits in the thousands place, because now we can just add the digits. And you'll see I've written this problem twice because we're going to go through this the first time just going through the basic process, and then the second time we go through it we're going to go a little bit slower and you'll really be able to understand behind the scenes what is going on here. So let's just run through the process and start by adding the digits in the ones place. So 2 plus 1 is 3. And 8 plus 6 is a double-digit number. It is 14. So we write the 4 in the tens place and carry over the 1 into the hundreds place. And then 1 plus 5 is 6, plus 7 is 13, which is also a double-digit number. So we write the 3 in the hundreds place and carry over the 1 into the thousands place. And then finally 1 plus 1 is 2, and so the answer is 2,343. So let's go through it a little bit slower this time, more explaining the process behind what's going on. So again, we start with adding the digits in the ones place. 2 plus 1 is 3. And then in the tens place, we have 8 plus 6. But this isn't really just 8 plus 6. This is in the tens place. So this is 80 plus 60. And 80 plus 60 is 140. And when we break down 140, we have 100, and we have 4 tens. That's why we write 4 in the tens place, and we write that extra 100 in the hundreds place. And then we have 1 plus 5 plus 7. But that's not really 1 plus 5 plus 7 because these are in the hundreds place. This is really 100 plus 500 plus 700, which gives us 1,300. And when we think about 1,300, we have 1,000 and we have 3 hundreds. That's why we write 3 in the hundreds place and carry over that extra 1,000 into the thousands place. And then we can just add up all the thousands. We have 1 plus 1, which is 2. And so that's how we get 2,343. And so when you go to do these problems, don't worry about doing all this extra stuff over here to the right. This was just to help you understand what's going on behind the scenes. When you actually go to add two numbers together, just do this process here on the left. So now go ahead and try this problem. There's one nuance to this problem that the other sample problem didn't really address, so I want to make sure you're able to do it. So go ahead, try this problem, pause this video, and then when you're ready, hit play again and we'll go through this problem together. Okay, so we start by adding the digits in the ones place. So 3 plus 2 is 5, plus 1 is 6. And then in the tens place, we have 8 plus 3 is 11, plus 4 is 15. So we can go ahead and write the 5 in the tens place and carry over the 1 into the hundreds place. And then in the hundreds place, we have 1 plus 6, which is 7, plus 9 is 16, plus 9 is 25. And so this is what I wanted to show you. We write the 5 in the hundreds place, and this time we have a 2 that we need to carry over into the thousands place. So we carry over the 2. And then finally in the thousands place, we have 2 plus 1 is 3, plus 2 is 5, plus 5 is 10. And so the answer is 10,556. So in this problem, you're making cookies. You have 20 eggs, and each batch of cookies requires 3 eggs. So how many batches of cookies can you make? And so we're going to solve this problem using a picture, and then we're going to figure out how to solve the problem a little bit quicker using just a little bit of math. So let's solve this problem using pictures. I've drawn 20 eggs here. You can count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I've grouped them into threes so we can see this very clearly. Each batch takes 3 eggs. And so how many batches can we make? Well, we can make 1 batch, 2 batches, 3 batches, 4 batches, 5 batches, 6 batches. And can we make a 7th batch? No, we cannot. We cannot make a 7th batch with just 2 eggs. And so the answer is 6. We can make 6 batches with our 20 eggs. And so how can we solve this a little bit faster just using a little bit of math and not having to draw these pictures? Well, we have 20 eggs and each batch divides these eggs into threes. And so what we can do is calculate 20 divided by 3, and what we find is that 20 divided by 3 is 6.6 repeated. And so we can make 6.6 batches in theory, but this isn't theory, this is practice. We can't make 6.6 batches. We can either make 6 or some other whole number. We can't make some fraction of a batch. And so we don't have quite enough for 7 batches. We only have enough for 6 batches. The answer is 6 batches. So before we go into this problem, let's very quickly review some terminology when it comes to place values. So we have this number 123.456, and this 1 is in the hundreds place, this 2 is in the tens place, this 3 is in the ones place, and then we have this decimal value 0.456. And anytime you're dealing with a decimal value, the word is going to end in ths or ths, like tenths, hundredths, thousandths. So this 4 is in the tenths place. Notice there's no such thing as a oneths place. There's a ones place, but not a oneths place. It goes straight to the tenths place. And then this 5 is in the hundredths place, and this 6 is in the thousandths place. So hopefully that helps you with recapping some terminology. And the reason that terminology is important is because the first step when adding these numbers is to align everything vertically based on place value. You align everything in the hundreds place, everything in the tens place, everything in the ones place, everything in the tenths place, everything in the hundredths place, everything in the thousandths place. You align the digits based on place value, because then the next step is to just add the digits starting on the right hand side, in this case with the thousandths place. And so let's go ahead and just do that. So we have nothing plus 4, which is 4, plus 7, which is 11. So we'll write this 11 up here just to make a note of it. So we're going to write the 1 here in the thousandths place and carry over the other 1 into the hundredths place. And then in the hundredths place, we have 1 plus 5, which is 6, plus 0, which is 6, plus 1, which is 7. And then in the hundredths place, we have 8 plus 0, which is 8, plus 1, which is 9. And then in the ones place, we have 3 plus nothing, which is just 3. And so the answer is 3.971. This problem is assessing your ability to convert a fraction into a decimal. And so we need to figure out the decimal form of 8/25. Now, I'm not sure if you're going to be given a calculator for this type of problem on the exam. If you are given a calculator, then this problem becomes very quick, because any fraction is really a division problem. 8/25 is the same as 8 divided by 25. And so if you have a calculator, what you can do is just plug into your calculator 8 divided by 25, and the calculator will tell you that the answer is 0.32. Now, if you don't have a calculator, we must do the division manually. Well, how do you do that? Well, we can set it up as a long division problem. 8 divided by 25 can be written like this. And we know that 8 is really the same as 8.00000, etc. And so 25 does not go into 8, so we can write a 0 up here and bring the decimal up. But 25 does go into 80, and it goes into 80 3 times. And 3 times 25 is 75. So we can subtract 75 in the form of 7.5, keeping the decimal in its place. And then 8.0 minus 7.5 is just 0.5, and we can bring all the zeros down. And now 25 does not go into 5, but it does go into 50, and it goes into 50 2 times. And then 2 times 25 is 50, and we can keep the decimal where it is, bring all the zeros down. And then 0.5 minus 0.5 is just 0. And when we get 0, that means the problem is done. We are done dividing. And so the answer is 0.32. So this is a long division problem. To figure out the remainder, we have to take 599 and divide it by 9. So let's do that. 9 does not go into 5, but it does go into 59. How many times? Well, 9 goes into 9 once, 18 twice, 27 3 times, 36 4 times, 45 5 times, 54 6 times, and 63 7 times. Now 63 is bigger than 59, so we can discard this. The most 9 goes into 59 is into 54, and it goes into 54 6 times. 9 times 6 is 54. So we write this 6 up here and subtract 54. And then down here, 59 minus 54 is 5, and then we can just drop this 9 down, and so we get 59. And then how many times does 9 go into 59? Well, we already know it goes in there 6 times, and so we'll write another 6 here, and once again subtract 54. And we're left with 59 minus 54, which is 5. There's nothing else to drop down, and so 5 is all we're left with. And so the answer is 599 divided by 9 is 66 and 5/9. And 5 is the remainder. 5 is what's left over, and so 5 is the remainder. 5 is the answer. So you're a machinist doing your machine things at a rate of 5.921 IPM, and you increase that to 6.08 8 IPM. And how much did you increase your IPMs by? And when you hear that language, how much did you increase it by? How much did you change it? What's the difference? That's a big indicator that we're working with a subtraction problem. And that's the first challenge of this sample question, is figuring out, is this an addition problem, subtraction, multiplication, division? What do we do with these two numbers? And we are going to subtract these two numbers. We're going to find the difference in how much we changed our IPMs. The next challenge is actually subtracting these numbers. And so what we're going to do is finish this problem. We're going to subtract these two numbers, and then I'm going to give you a few more examples to give you some more practice with subtracting numbers. And each of those problems is going to present to you a unique challenge. So let's move forward with subtracting these two numbers. The main insight here is to stack the digits based on place value. So you stack the digits in the hundreds place, in the tens place, in the ones place, in the tenths place, in the hundredths place, and in the thousandths place. And we start subtracting the numbers that are furthest to the right. So we begin with 8 minus 1, which is 7. And then 8 minus 2, which is 6. And then we have 0 minus 9. And 0 is smaller than 9. So what we need to do, and we'll get some more practice with this in the other examples, and I'll kind of go slower and explain what's going on. But for now, let's just do it. So 0 is smaller than 9. We need to borrow from the ones place and regroup what we borrow with what we have in the tenths place. And so now we have 10 minus 9, which is 1. And we drop down the decimal, and then 5 minus 5 is 0. And so the answer is 0.167. Now try these two problems. Try subtracting 158 from 442, and then try subtracting 13 from 400. Go ahead and pause this video, try these problems, and then when you're ready, hit play again, and then we will go through these problems together. So we're going to do problem number 1 in two different instances. This first time that we're going to run through it, this is the way I want you to solve these problems. This second way we're going to run through it is going to be a bit slower. I'm going to explain in detail why things are working, how things are going on, to really help you understand this problem deeply. So let's run through it the first time, just going through the process without much explanation. So we begin by stacking these two numbers, one on top of the other, by aligning the digits by place value. So we align the digits in the ones place, in the tens place, in the hundreds place, and we begin by subtracting the digits furthest to the right, in this case the ones place. So we have 2 minus 8, and 2 is smaller than 8, so we need to borrow from the tens place to make this 2 into a 12. And so now we have 12 minus 8, which is 4. And then we have 3 minus 5. But the 3 is smaller than the 5. So we need to borrow from the hundreds place to make this 3 into a 13. And so now we have 13 minus 5, which is 8. And 3 minus 1, which is 2. And so the answer is 284. So let's go through this problem again, just a bit slower so you can really understand what's going on here. So we have 2 minus 8. The 2 is smaller than the 8. How do we calculate 2 minus 8? You know, if this was 9 minus 8, then we know how to calculate that. 9 minus 8 is 1. But this isn't 9 minus 8. This is 2 minus 8. The 2 is smaller than the 8. So what do we do? Well, we borrow a 10 from the tens place and regroup this 10 that we borrow with the 2 that we already have in the ones place to make 12. Think of this as 42, and we're making it into 32. But this 10 that we borrow has to go somewhere. So we take this 10 that we borrow from the tens place and we repurpose it over to the ones place where we make 2 into 12. And so now we have 12 minus 8, which is 4. And then we have 3 minus 5. But this isn't really just 3 minus 5. This is in the tens place. So this is really 30 minus 50. But 30, once again, is smaller than 50. So in order to subtract this, we need to borrow from the hundreds place and regroup this 100 that we borrow with the 30 we already have to make 130, or in other words, 13 tens. And so now we have 13 minus 5, which is 8, and 3 minus 1, which is 2, and the answer is, once again, 284. So hopefully the way we did it on the right-hand side really helps you to understand deeply what's going on, why all this borrowing works, and what's happening. But when you go to subtract two numbers, you don't need all this extra notation. You can just do the process that we did the first time. And to subtract 13 from 400, we once again start by aligning the digits vertically based on place value. So we align the digits in the ones place, in the tens place, in the hundreds place. And we can start by subtracting the digits furthest to the right, which is in this case the ones place. So we begin with 0 minus 3. But 0 is smaller than 3, so we need to borrow from the tens place. But here's the thing. There's nothing in the tens place to borrow from. So we begin by borrowing from the hundreds place, and we regroup the 100 that we borrow with what we have in the tens place to get 10. And so now we have something in the tens place to borrow from, so let's do that. Let's borrow a 10 from the tens place and regroup the 10 that we borrow with what we have in the ones place to get 10. And so now we have 10 minus 3, which is 7, and 9 minus 1, which is 8, and 3 minus nothing, which is 3. And so the answer is 387. So we need to organize these numbers from least to greatest, and we have a number in decimal form, in percent form, and in fraction form. It's hard to compare these numbers when they're in different forms. It's easiest to compare these numbers when they're all in decimal form. So we're going to need to change this percent into a decimal and also this fraction into a decimal as well. So let's begin with the percentage. How do we convert 0.75% into a decimal? Well, we do it by moving the decimal 2 places to the left. So let's do that. We'll go 1, and then we'll need another 0, and 2. So we move the decimal 2 to the left, and so 0.75% is the same as 0.0075. Okay, how about the fraction? How do we turn this into a decimal? Well, any fraction is really a division problem. This is really 3 divided by 4. So they should give you a calculator for this problem, and if they do, then you can just plug this into your calculator. You can plug in 3 divided by 4, and the calculator will tell you that 3 divided by 4 is 0.75. Now, if they don't give you a calculator, then you'll need to do this division manually. Well, how do you do that? Well, you can set it up as a long division problem. 3 divided by 4 looks like this, and 3 is the same as 3.0000, etc. Now, 4 does not go into 3, so we can write a 0 here and bring up the decimal. So 4 does not go into 3, but it does go into 30, and it goes into 30 7 times. And 7 times 4 is 28, so we can subtract 28, keeping the decimal here. So it's really subtracting 2.8. So 3.0 minus 2.8 is 0.2, and we can bring down all of these zeros. And now 4 does not go into 2, but it does go into 20, and it goes into 20 5 times. And so 5 times 4 is 20, so we'll subtract 20, keeping the decimal where it is. And now 0.2 minus 0.2 is just 0, and when you hit 0, you know you're done dividing. And so 3 divided by 4 is 0.75. That is how you divide manually. Anyway, now we have 0.075, we have 0.0075, and we have 0.75. And so now we can see that 0.0075 is the smallest, followed by 0.075, followed by 0.75. Or in other words, 0.75% is the smallest, followed by 0.075, followed by 3/4. This is the correct answer. So we need to multiply 2.84 times 3.9. And if you need a refresher on how to multiply numbers vertically, please see number 2, where we go into these types of problems in detail. In this particular problem, we're going to focus on a couple of unique challenges that this presents because of the decimal places. And so the first thing we need to recognize is that 3.9 is the same as 3.90. And when you're multiplying decimals, it's important that you align all of the digits to each other. And so as a next step, we're going to rewrite this problem as 284 times 390. We're essentially going to ignore the decimal places for now, and we'll apply the decimal place as our last step. So let's just multiply these two numbers like we know how. And we begin with 284 times 0. And so 4 times 0 is 0. And 8 times 0 is 0, and 2 times 0 is 0. Now, that was important to multiply all those by 0 because now we're going to do the second row, 284 times 9. And when we do a second row, we buffer this second row with a 0. And so now we can do 4 times 9 is 36. And so we write down the 6, carry over the 3. And 8 times 9 is 72, plus 3 is 75. So we write down the 5 and carry over the 7. And then 2 times 9 is 18, plus 7 is 25. And then finally, we'll do 284 times 3. So now we're in the third row, so we'll buffer this third row with 2 zeros. And so now 4 times 3 is 12, so we'll write down the 2, carry over the 1. And 8 times 3 is 24, plus 1 is 25. So we'll write down the 5 and carry over the 2. And then 2 times 3 is 6, plus 2 is 8. And so now we can just add all these numbers together. 0 plus 0 plus 0 is 0. 0 plus 6 plus 0 is 6. 0 plus 5 plus 2 is 7. 5 plus 5 is 10, so we'll write down the 0, carry over the 1, and 1 plus 2 is 3, plus 8 is 11. And now we're not quite done. We have to deal with this decimal place. We need to figure out where to put the decimal somewhere in this number. Now, how do we figure that out? Well, we count how many numbers total are to the right of our decimal places. And we have an 8 that's to the right of a decimal, and the 4 that's to the right of the decimal, so that's 2 numbers. And then we also have a 9 and a 0. So altogether, that's 1, 2, 3, 4 numbers to the right of our decimals. And so we'll move the decimal 4 to the left. We'll go 1, 2, 3, 4, which lands us there. So our answer is 11.076. So we need to round 0.8637 to the hundredths place. And so I'm going to show you how to do this problem. And then we're going to go over a few other examples for you to practice so you can really get a handle on rounding to different place values and in different situations to really master rounding. So let's begin with recapping place value for this problem. So we have the hundreds place, we have the tens place, we have the ones place, we have the tenths place after the decimal, and then we have the hundredths place, the thousandths place, and the 10,000ths place. And so we need to round 0.8637 to the hundredths place. And so essentially we're going to get rid of anything after the hundredths place. We're going to get rid of this 3 and this 7, but it's not as simple as truncating the 3 and the 7 away. We must figure out if we need to round down to 0.86 or if we need to round up to 0.87. And it all depends on the value of the number that comes after what you're rounding to. So we're rounding to the hundredths place, and so we look to the thousandths place to see what this value is. Now, if this number is less than 5, in other words, if it's 0, 1, 2, 3, or 4, then we are going to round down. If it's 5 or greater, in other words, 5, 6, 7, 8, or 9, then we're going to round up. And so 3 is less than 5, so that means we are going to round down, and so the answer is 0.86. Now, if this 3 was a 5, then we would round up. The answer would be 0.87. But that's not the case for this problem. The value that comes after the hundredths place is a 3. It's less than 5. And so we round down to 0.86. 0.86 is the answer. So to really get a grasp on rounding, go ahead and try these problems out. Pause this video, try them out, and then when you're ready, go ahead and hit play again on the video, and we will go through these problems together. So to round to the nearest whole number, we need to round to a number that has no decimal value. So we look at the ones place and we see that it's a 0. And so the question is, do we round down to 0 or do we round this number up to 1? And to answer that, we look at the next value over, which is 8, and we ask ourselves, is this number greater than or equal to 5? And the answer is yes, it's greater than 5. And so when we round this to the nearest whole number, we round up to 1. And how about the tenths place? Well, to round to the nearest tenths place, we look at the tenths place and we say, okay, we have 0.8. Now, do we round this number up to 0.9 or do we round down to 0.8? And so to answer that, we look at the next digit over, which is 6. And we ask ourselves, is 6 greater than or equal to 5? And the answer is yes. And so we need to round up to 0.9. And so 0.9 is the answer for part B. For part 2a, we need to round to the thousandths place. And so we look to the thousandths place, which is at this 7 here. And we say, okay, are we going to round down to 23.047? Or are we going to round up to 23.048? And to answer that, we look at the next digit over, which is 4. And we ask ourselves, is 4 greater than or equal to 5? And the answer is no. And so we are going to round down to 23.047. How about part B? Well, once again, we look to the thousandths place and see that it's 7. And so we ask ourselves, okay, are we going to round down to 23.047 or are we going to round up to 23.048? And to answer that, we look at the next digit over and ask ourselves, is this digit greater than or equal to 5? And the answer is yes. And so that means we are going to round up to 23.048. So 60% of some mystery number is 30, and we need to figure out what this mystery number is. And whenever you have a situation where you're figuring out some kind of mystery number, you're typically going to deal with some kind of mathematical equation to solve for what this number is. And so the first thing we need to do is convert this English statement into a mathematical statement. And we'll do that piece by piece. So let's start with 60%. We can't really operate with 60%, add, subtract, multiply, divide. We first need to convert this into a decimal. And how do we do that? Well, to turn 60% into a decimal, we have to move the decimal 2 to the left. So we'll go 1, 2, and so 60% is the same as 0.6. or 0.6. And then moving on to the next piece, of is an indication that we're dealing with multiplication. So we'll have 0.6 times, and then we have some mystery number here. Now when we have a mystery number, we don't know what this number is, we denote that with a letter. So we'll call this mystery number x. We don't know what this number is yet, we just know it's a number. And then we have is another way of saying equals, and then we have 30. So now we have a mathematical statement. We have 0.6 times some number equals 30. And we need to figure out what this mystery number is. In other words, we need to solve for x. And so in the end, we would love to have something that looks like this. X equals some number. Because if we have x equals some number, then we know what x is. We know what the value of x is. We have solved for what this mystery number is. And we're actually very close to having that already. We have x equals some number, and the only difference between this equation here and this equation down here is that this 0.6 is next to this x. And so we need to get rid of this 0.6 somehow. We need to get x by itself. And how do we do that? Well, 0.6 is multiplying to x. So to get rid of the 0.6, we need to do the opposite of multiplication, and we need to divide both sides of this equation by 0.6. And when we do this, now we get 0.6 divided by 0.6 is just 1, and so these cancel out. And then we have on the right hand side 30 divided by 0.6. And 30 divided by 0.6 is 50. And so on the left hand side we just have x, and on the right hand side 30 divided by 0.6 is 50. And so we have x equals 50. We have solved for what this mystery number is. 60% of 50 is 30. So 50 is the correct answer. So we have some mystery number p, and we need to figure out if p is between 3 and 4, or between 5 and 6, or between 6 and 7, or between 7 and 9. And so we need to figure out the value of p, what number p is. And then once we know what number p is, then we know which of these options is correct. So let's figure out the value of p. We know that p is equal to 4/3 divided by 1/6. And so we'll need to divide these fractions. And if you don't remember how to divide fractions, please go back to number 3, where we covered all the different types of fraction operations, including division. So let's go ahead and divide these fractions. We know that p is equal to 4/3 times 6/1. So when we divide fractions, we turn it into a multiplication problem. And all we need to do that is take the second fraction and take its reciprocal. So we make the numerator the denominator into the numerator. And so p is equal to 4/3 times 6/1. And when we multiply fractions, we multiply across. And so we get p equals 4 times 6 is 24. And 3 times 1 is 3. And so p is 24/3. Now, any fraction is really a division problem. So this is 24 divided by 3, and 24 divided by 3 is 8. So p is 8. And so is 8 between 3 and 4? No. Is it between 5 and 6? No. Is it between 6 and 7? No. Is it between 7 and 9? Yes. And so p is between 7 and 9. This is the correct answer. So before we get into this problem, let's cover inequalities and all the different types. So first of all, we have equalities. So equalities are anything that has an equal sign. It's your equations. So for example, 5 is equal to 5. This is an equality. But then we have inequalities. So we have less than, greater than, less than or equal to, and greater than or equal to. And a whole bunch of different examples down here. So for example, this expression says 4 is less than 5. And we can read this left to right, or we can read it right to left. So if we read it left to right, we say 4, and then we hit this pointy part of the symbol here. The pointy part means less than. And so this reads 4 is less than 5. Now if we read it right to left, we say 5, and then we hit the open mouth part of the symbol. The open mouth means greater than. So 5 is greater than 4. You can read it left to right or right to left, and it's true. And similarly down here, this says 5 is greater than 4. Or if we read it right to left, we say 4 is less than 5. And then down here we have less than or equal to. So for example, we have 4 is less than or equal to 5. And is that true? Yes, because it's less than or equal. In particular, it's less than. How about this one? This one says 5 is less than or equal to 5. Is this one true? Yes, it is, because 5 is less than or equal to 5. Namely, it's equal to. And then down here we have 5 is greater than or equal to 4. And is that true? Well, yes, because it's greater than or equal to 4. Namely, it's greater than 4. And down here we have 5 is greater than or equal to 5. And is this one true? Yes, it is, because 5 is greater than or equal to 5. Namely, it is equal to 5. So these are all the different inequalities: less than, greater than, less than or equal to, and greater than or equal to. So we need to evaluate which of these inequalities is true. And so we can begin with part A. We need to determine whether 3/4 is less than 5/7. We need to figure out if this is true or not. And it's kind of difficult to evaluate this when we have fractions with unlike denominators. We have a 4 and a 7. They are not common denominators. And so what we can do is convert these fractions into decimals. And when we do that, then we'll be able to more clearly tell whether this statement is true or not. So let's do that. How do we convert fractions into decimals? Well, any fraction is really a division problem. 3/4 is really 3 divided by 4. And so we can use a calculator to plug in 3 divided by 4. And when we do that, it says that 3 divided by 4 is 0.75. And then when we plug into the calculator 5 divided by 7, the calculator tells us that that is 0.71. And so is it true that 0.75 is less than 0.71? No, it is not. This is not true, and so part A is not true. How about part B? Is 2/3 greater than 5/6? Well, let's find out. Let's plug into our calculator 2 divided by 3, and that will give us 0.6 repeated. And 5 divided by 6 in our calculator will tell us that this is 0.83 repeated. And is 0.6 greater than 0.83? No, it is not. This is not true, and so part B is also not true. How about part C? Is 5/8 greater than 6/10? Well, let's find out. We'll plug into our calculator 5 divided by 8, and we get 0.625. And when we plug into our calculator 6 divided by 10, we get 0.6. So is it true that 0.625 is greater than 0.6? Yes, this is true, and so C is true. This inequality is true. 5/8 is greater than 6/10. And then just for funsies, we can do part D to evaluate whether this inequality is true. So is 4/5 less than 2/9? Well, let's plug into our calculator 4 divided by 5, and we get 0.8. And then 2 divided by 9, we get 0.2 repeated. And so is 0.8 less than 0.2 repeated? No, it is not, and so part D is not true. This inequality is not true. C is the only inequality that is true. C is the correct answer. So I think it's very likely that you'll get a calculator to solve this type of problem on the exam, but I want to run through this a second time without a calculator just in case, and also because it's really good to get the practice to really get some mastery over fractions. And so let's start with part A and evaluate whether 3/4 is less than 5/7 without using a calculator. Again, it's hard to do this when the denominators of the fractions are not the same. And so we need to make the denominators the same, and then we can easily tell whether this inequality is true. And if you need a refresher on how to make the denominators the same, I recommend going back to sample question 3, example number 6, because we go into great detail on how to do this. But we'll still run through the steps here. So to find the common denominator, a trick is just to multiply the denominators together. So 4 times 7 is 28. So this is going to be our denominator. And so now we need to restate 3/4 in terms of 28. How do we do that? Well, we ask 4 times what number equals 28? Well, 4 times 7 equals 28. So to convert 3/4 into 28, we take 3/4 and we multiply it by 7 over 7. And when we multiply across. So 3 times 7 is 21, and 4 times 7 is 28. And so 3/4 is the same as 21 over 28, and now we have the denominator 28. How about 5/7? So to convert 5/7 into 28, we ask 7 times what number is equal to 28? Well, 7 times 4 is equal to 28. And so to convert 5/7 into 28, we take 5/7 and we multiply it by 4 over 4, and we get 5 times 4 is 20, and 7 times 4 is 28. And 5/7 converted into 28 is 20/28. And so now 3/4 is 21 over 28. And 5/7 is 20 over 28. And so is it true that 21 over 28 is less than 20 over 28? No, it is not. 21 is not less than 20, and so part A is not true. So how about for part B? Well, once again, we need to find common denominator. And so this time the 3 actually multiplies into the 6. And so we can keep the 5/6 the same. Our common denominator is going to be 6. We just need to restate 2/3 in terms of sixths. So how do we do that? Well, we ask 3 times what number equals 6? Well, 3 times 2 equals 6. And so to convert 2/3 into sixths, we just multiply 2/3 by 2 over 2, and we get that 2 times 2 is 4, and 3 times 2 is 6, and so 2/3 restated into sixths is 4/6. And now we can evaluate this inequality. So 2/3 is really 4/6, and 5/6 is just 5/6. And so is 4/6 greater than 5/6? No, it is not. 4 is less than 5. 4 is not greater than 5, so B is not true. And how about part C? Well, once again, we need the denominators to be the same. So what is our common denominator going to be? Well, 8 times 10 is 80, so we'll go with that. So we'll need to restate 5/8 into 80ths. And how do we do that? Well, we say 8 times what number is equal to 80? Well, 8 times 10 is equal to 80. And so to restate 5/8 into 80ths, we just take 5/8 and multiply it by 10 over 10, and we get that 5 times 10 is 50, and 8 times 10 is 80, and so 5/8 is the same as 50/80ths. So we need to restate 6/10ths in terms of 80ths. How do we do that? Well, we ask 10 times what number is equal to 80? Well, 10 times 8 is equal to 80. And so to restate 6/10ths in terms of 80ths, we need to take 6/10ths and multiply it by 8 over 8. And then 6 times 8 is 48, and 10 times 8 is 80, and so 6/10ths is the same as 48/80ths. And now we can evaluate this inequality. 5/8 is the same as 50 over 80, and 6/10ths is the same as 48 over 80. And so is it true that 50 over 80 is greater than 48 over 80? Yes, it is. 50/80ths is greater than 48/80ths, and so C is true. So the first step in this problem is to break down that long paragraph of information and pull out the most important parts. And when you see numbers, that's a pretty good indicator that that's an important piece of information that we need to pull out. So here's all the important information. We spent 1/4 of our 28 days working at the bookstore. We spent 1/14 of our 28 days off, and we spent all the remaining days working at the restaurant. We need to figure out how many days we worked at the restaurant. So thinking about this strategically, if we can figure out how many days we spent working at the bookstore, how many days off, then we can figure out how many days we worked at the restaurant. It's just the rest of the 28 days. So to figure out how many days we spent working at the bookstore, we need to take 1/4 of 28. And when we see this of, that's a big indicator that we're working with multiplication. So we need to multiply 1/4 times 28. So let's do that. 1/4 times 28. Now, how do you multiply a fraction times a whole number? Well, I'll show you a trick. So 28 is the same as 28 over 1, because 28 divided by 1 is just 28. And so we're really multiplying by 28, it's just that we're multiplying it in fraction form, because we know how to multiply fractions. We just multiply across. So 1 times 28 is 28. And 4 times 1 is 4, and then 28 divided by 4 is 7. So we worked 7 days at the bookstore. And then how many days did we have off? So we need to take 1/14 times 28. So we're going to write 1/14, and we're going to multiply it by 28 over 1. And now 1 times 28 is 28, and 14 times 1 is 14, and 28 divided by 14 is 2. So we spent 7 days working at the bookstore. We had 2 days off. And so of the 28 days, we spent 9 days not working at the restaurant. And so if we take away this 9 days that we didn't work at the restaurant, we will have our answer. And if they give you a calculator for this problem, you can just plug in 28 minus 9 and you'll get your answer. If you don't have a calculator for this, then you'll need to subtract manually, and you need to align the digits based on place value. So we've aligned the digits in the ones place and the digits in the tens place. And now we just need to subtract these digits, starting with the digits furthest to the right, in this case, the ones place. So we take 8 minus 9, but 8 is smaller than 9, so we need to borrow from the tens place to make this 8 into an 18. And so now we have 18 minus 9, which is 9, and 1 minus nothing, which is just 1, and so the answer is 19. We spent 19 days at the restaurant. Thank you for studying with me. If you thought this was helpful, please hit like, subscribe, and the notification bell below this video to let others know that this video is awesome, and so you can stay up to date on all my videos on how to crush the Accuplacer math exam.